Greetings, this is M Squared. We're going to solve some more linear systems by graphing. Just a reminder that three things can happen when I solve linear systems, which means I'm finding out where two lines intersect. They can intersect in exactly one point. They can be the same line and have an infinite amount of solutions because they intersect in every point, or they can be parallel and have no solutions. So we'll keep that in mind as we're solving these two systems. So you want to get the equations in slope-intercept form. This one has y alone, so it's already in slope-intercept form. My slope is 3/2. Over here I need to divide by 4 to find the slope-intercept form. And 6 divided by 4, if we reduce that, is 3/2. And 28 divided by 4 is -7. Now what I want you to notice is that the slopes are the same and the y-intercepts are the same. That means these lines are the same line. So I'm going to have an infinite amount of solutions. So really you only have to graph that one line. So 1, 2, 3, 4, 5, 6, 7. And then that's the y-intercept. And the slope is 3/2, so I would go up 3/2. And the same line as the other one, so really there's no need to graph again the same line. So you would just say, you could use the little infinity symbol and say an infinite amount of solutions. And if they asked you about being consistent or inconsistent, that kind of thing, these would be consistent and dependent. Dependent because of the same line. Dependent. We'll abbreviate. Sorry about that. Okay, the next one, we need to get these in slope-intercept form. So this y is easiest to get alone if I just bring it over here. So I'm going to add y to both sides, and I get 3/4 x equals y. Notice that there's no b, which means our y-intercept is 0. Over here, to get y alone, first I need to move the 1/2 x over, and then I'll get rid of that 1/3. So first I have 1/3 y equals -1/2 x plus 6. To get rid of the 1/3, I multiply by 3, and I have to do that to every part. So now I have y equals -3/2 x plus 18. So I see that my slopes are different, so I know they're going to intersect at least once. So we'll start by graphing this one. Y-intercept is 0. But before I do that, let me stop. My graph only goes 10 up and 10 down. You might have little graphs like this, or you might have regular graph paper. Even if you had regular graph paper, a y-intercept of 18 is going to take up quite a bit of room. So sometimes you want to switch what you're counting by instead of counting by ones. So what I'm going to do is switch this whole graph to counting by 2s. And if I put a 2 here and a 2 there, that means on the x-axis I'm counting by 2s, and on the y-axis I'm counting by 2s. There's no need to do every single, 2, 4, 6, up and down, positive and negative, if you just establish what you're counting by. So that means when I go up 3 and over 4, I can do it one of two ways. So since I'm counting by 2s in both directions, I could still go up 3 and over 4, or I could go up 1, 2, 3 and over 1, 2, 3, 4. Notice that no matter either way I did it, that I'm still on that same line. So I could go down 3 and over 4. So that's my one line. Now I'm going to graph this line. 18 is the y-intercept, so I'm going to go up 2, 4, 6, 8, 10, 12, 14, 16, 18. And my slope is -3/2. And again, because I'm counting the same y on my y-axis and my x-axis, I can just actually go down 3 and over 2. But it's negative, so I have to be careful that I go down. My slope is down. And we see that this is the point of intersection, so this has one solution. But be careful when you're counting. Remember, we're counting by 2, so when we write the solution, we want to count correctly. So it's 2, 4, 6, 8, and then 2, 4, 6. So our solution is 8, 6. That makes this consistent and independent because it intersected once. And you can always check by plugging it back in there. If you put the 8 in here, 8 divided by 4 is 2. 2 times 3 is 6, and here's another 6. So 6 minus 6 is 0. If you plug it in over here, 1/3 of 6 is 3. 1/2 of 8 is 4. Wait, 1/3 of 6 is 2. My apologies. 1/2 of 8 is 4, and 2 plus 4 is 6. It's always important to check, because if you check your solution into the original equations, you'll know right then if you are correct or not. It's really important to check, especially on a test or quiz, because there's no excuse for getting these wrong if you can just check it and then go back and find your mistake. So check, check, check. And good luck with that. M Squared signing out.